So, hi everyone. Thank you for coming to this session about what's new in Spring Batch 5. My name is Mahmoud. I am the lead of Spring Batch at VMware. It's my first Spring I/O, so I'm very happy and excited to be part of this event. So what's new in Spring Batch 5? So this is a major release. This is a huge release. I'm going to start by talking about the new baseline, both in terms of Spring dependencies and the minimum Java version in this release. After that, I'm going to talk about the major new features and changes in this release. And then I will show you what we have removed in this release. And finally, I will finish my presentation by giving you some important details about the support policy and what's coming next. So, as with every major release, we upgrade Spring dependencies to their respective major releases as well. So in Spring Batch 5, we have Spring Framework 6, Integration 6, Data 3, and so on. So all of these are major releases as well, Micrometer as well, despite the minor version number there, 1.10, but it's still a major release as well. So we upgraded to these, and as you know, for Spring Framework 6, the new minimum Java version required is Java 17 for the standard edition and Jakarta 9 for the enterprise edition. And because Spring Batch is based on Spring Framework, so we had to upgrade the minimum Java version for Spring Batch as well, which is the same basically. So Java 17 for the standard edition and Jakarta 9 for the enterprise edition. So this was a bit controversial when we first announced it. People felt like this is an aggressive move from Java 8 to Java 17. But I believe this is a good choice and the right choice. If you think about it, we are releasing major releases for all the projects in the portfolio, and those are for the coming years, 3, 4, 5 years from now. And based on the release cadence of Java from Oracle twice a year, so in 5 years, maybe we will have 10 Java versions released from now. So if we stay on Java 8 now, we will be in 5 years maybe on Java 30. So we will have to support from Java 8 to Java 30, which is, of course, a very long time frame, and we can't do that. So I think it's the right time to move to Java 17. Of course, this is beneficial to you as users to have Java 17 as a platform to run your batch applications on, and for us also as framework developers, because we have new features we can use to implement new features in Spring Batch as well. And I wanted to share with you some numbers from a talk from an Oracle program manager about the new features from Java 8 to Java 18. So here, at some point in the presentation, he talks about the runtime performance improvement of the JDK. So here is the startup time of a Hello World application in different Java versions. And you see between Java 8 and Java 17, the startup time is almost 2 times faster. So that's a great improvement just by upgrading to a newer Java version. And later in the presentation, he talks about the memory footprint as well. So here again, for the same application, same garbage collector, we have a better memory management, memory footprint. The blue line is JDK 8. And the gray line is JDK 17. So we see a great improvement here as well. So having Java 17 as a baseline, I think, is already a feature as a batch user, having this platform to run my batch applications on. As I said, so this is beneficial to you as users, also for us as framework developers, because we have new APIs we can use to implement new features. And with that, I'm going to move to new features. And the first one is Java record support updates. So we introduced Java record support already in 4.3. So, and since then, we fixed a couple of bugs. We added a new field extractor for Java records, which is similar to the bean wrapper field extractor for Java beans. So this is a similar API. So in Spring Batch 4, we are based on Java 8. So we don't have any Java lang record API yet in the GDK that we can use, but this didn't prevent us from providing initial support for records. So we used some reflection hacks to try to support them and give users a feeling of how can Spring Batch support records. But now that we have the Java 17 as a baseline, we can use the Java lang record API to correctly implement record support. And this is what we have done. So we changed a couple of implementations that were based on reflection to use the Java lang record API. And also we added new features like the automatic configuration of mappers in item readers based on item type. Also the configuration of extractors on item writers, also based on item type. So for those who are not familiar with these, basically we have mappers are used when you read data from a file, for example, or a database, and you want to map it to a Java object. Here we use mappers when reading. And when we write, on the other side, we want to extract fields from these objects to marshal them to CSV, XML, something. And this is where we use extractor, and we set them on item writers. So this was done manually in Spring Batch 4. And in Spring Batch 5, we implemented this feature to automatically configure them based on the item type, if it's a class or a record. And you will see why this is important. So I have an example for this. So here is the example. I have a person class, ID name, and I want to read data from a person's CSV file, okay? So this snippet is how I would configure a flat file item reader with Spring Batch. So I use a builder, and then I say, here is the resource where to read data from, and please map each line of this file to this target type, person.class. Okay. So now I'm expecting Spring Batch to configure a bean wrapper field set mapper on this reader, because my type is a class. And what if I change this person class to a person record, like now? So now I'm expecting to change the implementation of the mapper from bean wrapper field set mapper to a record field set mapper. And here, I'm not expecting to write any modification to my item reader. So the idea is that if tomorrow you have a bunch of classes and you want to migrate them to records because you moved to Java 17, our goal is that you don't have to change any item reader definition or item writer definition. And this is thanks to the Java lang record API that we use inside this flat file item reader there. Somewhere we have in the builder, somewhere in the builder, when we build the flat file item reader, we can introspect the type and configure the mapper accordingly. So this was not possible in Spring Batch 4. We didn't have this isRecord method there. So now it's possible. And this is the kind of nice feature we can have thanks to these updates. So if you migrate your types, imagine those types are not under your control. You grab them from a jar of some other people who designed these types, and they decided to move from classes to records. You are covered. You don't have to. I do like Josh. Hey. Thank you. So you don't have to change your item readers or writers definitions, and you are covered. Okay. So this is the first feature. The second feature, which is mostly the most impactful on you as users, is the batch configuration update. So those are changes that impact how we configure Spring Batch. Okay. So we have two main themes here: the declarative approach of configuring Spring Batch through an annotation, enable batch processing, and another one, which is the programmatic way, and we will see that in a minute. So let's start with enable batch processing. So if you are using Spring Batch, you should be familiar with this annotation. It's an old one from version 3, I guess. So for those who are not familiar with this, you add this annotation on the configuration class, and it registers for you some useful infrastructure beans, like job repository, job explorer, and so on. Those can be used to define your jobs and steps and so on. So in this example, I have job repository, which is auto-wired from the context, and it was registered in the context by enable batch processing. So nothing new here in 5, so in version 5. What we have changed, though, is the way to customize the behavior of that annotation. So how to customize the job repository that was registered by enable batch processing. So in Spring Batch 4, in order to customize the enable batch processing annotation, we had to implement an interface, batch configurer, or extend the class, default batch configurer. So for example, if I want to use a custom data source, I need to provide a bean of type batch configurer and override the method to use this custom data source. So there is a design flow with this approach. So I am in a declarative approach. So I am not supposed to write code. It's declarative. As a user, I want to configure things declaratively, purely declaratively, without implementing an interface, without extending a class. This is not the case. So I am using the annotation, but I still have to implement an interface. So this is not the way to go. So how can I do this? How can I tell Spring Batch to use my custom data source without implementing the interface or extending a class? The most natural way we found is to tell Spring Batch to use the data source through the attribute of the annotation. So imagine I have my custom data source bean in the application context. I can tell Spring Batch to use that data source using the attribute data source ref and point it to my custom batch data source. There is no interface to implement, no class to extend. This is purely declarative. Does this make sense? Okay. Now, it could be even more impressive when we have to configure a property that should be set on the job explorer and the job repository and maybe another component, like, for example, a custom serializer. So imagine I want to use a custom serializer for a custom type. I need to set it on the job repository when I serialize data, and I also need to set it on the job explorer when I deserialize data. So this is how we do that in Spring Batch 4. It doesn't fit on a single slide, which means it's wrong. Okay. I have the custom serializer, and I need to set it on the job repository here and the job explorer. So I override two methods, and I set it here and here. That's how inconvenient it is to configure a custom serializer in Spring Batch 4. Of course, this is wrong, and we don't want you to write all this code. So how can I do this in Spring Batch 5? Same idea. All I have to do is to declare my custom serializer in the application context and tell Spring Batch to refer to that using an attribute of enable batch processing. That's a lot better, I think. Less code, less bugs, less everything. Of course, this custom serializer can be defined manually, or it could be auto-configured by Spring Boot if you use Spring Boot. So I can imagine these lines of code are not there. I only have enable batch processing with this attribute, and I'm done. So that's a big change, I think, and it's more straightforward. So this is the first part, which is the declarative way. Now I think it's purely declarative. I don't have to implement an interface or extend the class. Now what if I want to implement an interface or extend the class to have control, to write some code and configure beans as I wish? So we need a programmatic counterpart for this. And that's why we introduced a new class, which is called default batch configuration. So this is a base class that you can extend. So you will get exactly the same beans, infrastructure beans, from the like enable batch processing that you can use to define your jobs and steps and so on. And now if I want to override something, a parameter or a bean or something, I can override the method. Like here, I can override get data source and provide my custom data source. This data source will be, of course, set on the job repository, job explorer, and all the beans. I don't have to implement 2 methods or override 2 methods. So yeah, this is the counterpart of the enable batch processing. And now we have 2 ways of configuring Spring Batch, declarative and programmatic. So yeah, that's all for batch configuration updates. The next big change is about job parameters handling. This is also impacting, I think, for end users. And the first part is about parameter conversion. So how do we convert parameters from string literals on the command line to actual types? So in Spring Batch 4, we have this notation to specify parameters. So it's a specific key value pair. It's not a standard key value pair notation. So we have plus minus for the identification flag, then the parameter name, and then between parentheses, the type equals the value, which is string literal. I have an example here, java-jar myjob.jar, dash schedule date, the parameter name, and then between parentheses date equals value. Okay. What's wrong with this notation? A couple of things. The first one is this dash here. This dash doesn't play well with Spring Boot. As you know, in Spring Boot, we specify application parameters with dash dash parameter. And when we parse those application arguments, we remove these dashes. The problem is that when we remove these dashes, one of them has a meaning for Spring Batch to specify that this parameter is not identifying. So we lose the meaning of this dash. And that's an issue. The second issue with this notation is the parenthesis. In some circumstances, we pass job parameters as environment variables, like in Spring Cloud Dataflow, for example, when we run batch applications in containers. We pass parameters as environment variables, and we cannot use parentheses as keys in the environment variables. So it is just impossible. So that's another issue. And the third issue is that the type between parentheses is ambiguous. Why? So date, okay. What type of date? Java util date, Java SQL date, Java time, local date, I don't know. So I need to read the documentation. And whenever you tell users to read the documentation, they will simply don't do it. They will ask a question on Stack Overflow, they will ask ChatGPT, they will send you an email, they will do everything except reading the documentation. So we need to fix this. And we need to make this type as explicit as possible. And this is how we are going to fix that in V5. Okay, so in V5, we have a new notation, which is a standard key value pair with a specific interpretation for the value. So we have the parameter name equals a comma-separated string. The first part is the value of the parameter, the second one is its type, and the third one is the identification flag. Okay? In the example, java-jar, myjob, so on, schedule date equals the date value, comma, the fully qualified type name. So it's not ambiguous anymore. And then I can add comma true or false for the identification flag. So here I omitted on purpose the flag to show you that we can use some defaults. So if the flag is not there, it's true by default. We can also imagine with this notation, if we omit the type, it's a string or something like that. Anyway, we have this key value pair. So now I think the issues we had with V4 just disappear. We don't have a dash before the parameter name. We don't have parentheses. The type is explicit. We can do more explicit than that. It's a fully qualified name, so people will write it down. So it's there. One issue can happen here. What could go wrong? Trying to make this interactive. Sorry? Date format. Yeah, the date format I can change it. Exactly. So what if the value contains comma? So we don't know how to parse this. We will have like half of the value or the other part is part of the type and so on. So that's the reason why we added another notation, which is the extended notation. And here is the same thing, key value pair with a specific interpretation for the value, meaning it's a JSON object instead of a comma separated list. So now if there is a comma in the value, we know how to pass this in JSON, and there is no issue with that. So this is actually inspired by the Spring application JSON, if you are familiar with that. So we have this variable that you can pass to Spring Boot, and it's a system property, and you can pass parameters as a JSON string. So this is the same thing. If you are using this, you should feel at home when you use this notation with Spring Batch. So that's the first part, how we convert parameters from string literals to typed values. The second one is about the types themselves. So in Spring Batch 4, we have 4 supported types: string, long, double, and date. The question here, how can I pass a Boolean or something? So I have to do some conversion myself. So Spring Batch 4, we have 4 types. Spring Batch 5, we have 5 types. No, any type. So Spring Batch 5, you can use any type as a parameter. And the idea is that if I have a custom type, like in this example, I have a batch job that exports orders for a given customer, I want to pass the customer as a parameter type, foo, of type my domain customer. So how can I teach a Spring Batch to convert this foo string to an instance of my domain customer? And this is where we use the conversion service from Spring Framework. So there is already a service in Spring Framework, APIs as well, converter, and so on. And we use these in Spring Batch now. So you can leverage that and register converters from string to your types and vice versa, and tell Spring Batch how to do that. And now I will show you an example how you provide custom types. So you have your regular Spring Batch application configuration. You can register a bean of type configurable conversion service. So that's a custom conversion service in which you register your custom converters and tell Spring Batch through enable batch processing an attribute there. Please use that conversion service for parameters. So that's a huge improvement, I think, because we don't need anymore to convert Booleans and do the conversions and so on. So it's based on Spring Framework, and it's a lot better than before. Okay. Now another feature and a couple of major changes regarding batch metadata. So this is all related to the schema in the database and so on. First, we added support for a new database, which is SAP HANA. So HANA now can be used as a backend, as a job repository for batch metadata in Spring Batch 5. And we also added support for MariaDB. So MariaDB was already supported, but it was considered as MySQL. So it's a fork of MySQL, and for a long time, when you use MariaDB with Spring Batch will use the DDL of MySQL, the incrementer of MySQL, and so on. And at some point, these forks, the fork, they diverged, and there is a feature disparity there, and so on. So I think it's the right time to consider MariaDB as a separate product, and we now have it has its own DDL script, incrementer, and so on. Another change is about the execution context. So we changed the default format. In Spring Batch 4, it was JSON backed by Jackson. In Spring Batch 5, it's now base 64. So why we did that? So a couple of reasons. Spring Batch 4 has a compile time dependency to Jackson. Okay, this is problematic because some people want to use other JSON libraries and they have Jackson in the class path just by importing Spring Batch. So Jackson was opt out instead of opt in. So you have to tell Spring Batch to exclude Jackson instead of telling it to include Jackson, and this is not correct. The other reason is that Jackson was So definitely is one of the best JSON processors on the JVM. The problem is that they don't respect semantic versioning rigorously, which impacted us in many ways. Sometimes you have breaking changes in patch versions, minor versions, CVEs, and so on. And this is a maintenance burden on us. So we have to find a way to make it optional. And yeah, so we had to find a serialization format that we can use from the GDK without depending on Jackson. And the most natural choice was base 64. So in Spring Batch 5, Jackson is optional. If you want to use it, you can. So the serializer is still in Batch 5. You just add the dependency, and you tell Spring Batch to use JSON. Another improvement is about the metadata, so that we put inside the execution context. We added a new attribute called batch version. So this is a runtime information. We take it from the jar. This is useful if you debug your execution context. If you migrate from one version to another, you can know which version was used, or the version that was upgraded from and to, and so on. So this is a new attribute that we put there. Schema updates. Here we changed the database in many ways. For example, for Microsoft SQL Server, we used to use tables to emulate sequences. So this is technical, but yeah. Using tables to emulate sequences while you have sequences in SQL Server since 2012, I think, or 13. So yeah, we had to change that to use real sequences and not emulating them with tables. We also added a bunch of columns and so on. I just wanted to tell you that we have some database changes here. Those, for example, are for the job parameters, parameter name type, and so on that I showed earlier. But yeah, we have a list of all these changes in the migration guide. But yeah, if you migrate, get ready to apply some DDL changes to your databases. Okay, the next feature, which is quite interesting, batch observability. So this is actually one of the main themes in the entire portfolio. So it's an effort across the entire portfolio. Every project has, in some capacity, tried to improve observability. And Spring Batch is no different. We have metrics, which are already supported in Spring Batch, and we added tracing in Spring Batch 5. So this is what I'm going to show you now. So for metrics, we have several improvements since for the 3, of course, bug fixes. We changed the tag names to be consistent between metrics and also between how they are, the metrics, how they are tagged, even compared to other projects. So we use a consistent naming between like Spring Batch and other projects. We upgraded the usage of observability APIs to Micrometer 1.10. As I said, this is a major release despite the minor version number. But yeah, they changed a lot of APIs and we had to change them in batch as well. And we also added a couple of new metrics. The first one is the currently active step. This is very useful when you have a job with a lot of steps and at some point you want to know which step is currently running. So you have like a metric for that. And the other new metric is the job launch count. So if you have a job launcher in the application context, you can know how many jobs were launched using that launcher. So if you have a dashboard, you can see like, since today we launched 100 job instances, like for example. So how to enable metrics? Metrics are not enabled by default. We don't want to add any overhead without your agreement, so you have to enable them. And all you have to do is to add a observation registry bean with the metric backend, as long as it's supported by Micrometer, and you are done. So with this bean, metrics are enabled, and they should be, of course, sent to your metric backend regularly. So that's all for metrics. Now tracing, which is very interesting, and I'm very excited for this feature. The idea of tracing is a bit different than metrics. So metrics, like you have aggregate numbers and so on. Tracing, on the other hand, is like you follow the execution of your job step by step, instruction by instruction, and you can send those tracing data to a backend and then see them on a dashboard. And I have a screenshot here from Zipkin. So the idea is to have something like this. So when I see this, I can immediately see that I have a trace for a job execution here. And I see that I have two steps. I have the execution time of each step, the execution time of the entire job, and so on. This is already very interesting because you can follow and you can trace the execution step by step. What's interesting also is that if I activate database tracing, for example, I can see all the interactions of my batch job with the database. And I can see the execution time of each query. If I have slow queries, if I have like an issue with database access transactions and so on. Also, we have support to trace web components, REST templates, and so on. So if my batch job sends a REST request, for example, I can trace the request. I can see how long it takes, and so on and so forth. Of course, I can also see other information about the tags, like the execution ID, the status, and so on. So this is very nice. I use it in all my jobs since Spring Batch 5 to trace. If you have parallel steps, you can see them in parallel as well. So for partitioning, for example, it's a very cool feature, I think. How do I activate tracing now? So it's similar to metrics. You have this observation registry. Obviously, you have to configure a tracer supported by micrometer, like Brave or OpenTelemetry or something. And when you have this tracer configured, you just need to add the tracing handler using that tracer. Of course, if you use Spring Boot, this will be automatically configured for you, but you can, of course, use it without Spring Boot if you want to configure it manually. So it's literally one line of code, and you have like tracing data sent to a backend, which is great, I think. Kudos to the observability team for making this as easy as one line of code. So yeah, that's excellent. Okay, the last major feature I want to talk about, I kept it for the end. GraalVM support. I'm really excited about this one, and you will see it's a game changer, I think. So GraalVM native support improvements. We introduced a GraalVM support in 4.3 as in beta in 4.3. We improved a lot of things since then: bug fixes, performance improvement, tooling improvement. This is actually an effort across the portfolio. So Spring Framework to provide the building blocks, APIs for other projects to provide hints and so on. I will talk about them in a minute. Tooling in the Spring Boot team. Of course, all projects had to do some work to make sure applications are correctly natively compiled. And for this, for example, for batch, we added the native hints for AOT processing by Spring Framework. Of course, we have a lot of types, and we added all of these in Spring Batch, so you can natively compile batch applications and run them with GraalVM. So how can this be beneficial to you? So yeah, so it's for performance, for startup time, for memory usage, and so on. And for that, we have done two benchmarks. We try to compare a natively compiled application, the same application that runs on a regular VM and on as a natively compiled app. And I have two types. So a hello world. Let's start with this one. So a hello world is a Spring Batch job with a single step, printing hello world. So for this, we have a first metric, startup time. So the first one, the orange, is the JVM startup time. Second, more than a second. And the native app starts in 44 milliseconds. This is roughly 20 times faster. 30 times maybe. Almost 30 times. Yeah, the startup time is not really indicative for batch applications. So if it runs for a few minutes or hours, I don't really care if it starts in a second or half a second. What's more important, I think, is the total execution time. And here I have, for the regular JVM app, 26 milliseconds. And for the native app, ready? 1 millisecond. Okay, 26 times faster, and this is on my Intel machine here. This is an average execution. I mean, I tried like a dozen times. It's 1, 1.5, and so on. On Apple Mac M1, it was like 35, 40 times, like 40 milliseconds for the JVM and 1 millisecond for the native. I think this is like huge, and kudos to everyone who is working on this, from the GRAALVM team, from Spring Framework, everyone. If you have 25 times speed up, imagine you are running your batch workloads on a cloud platform that is built by CPU, time, memory, and so on. This means 20 times cheaper on your invoice. I mean, you can ask for a 25% raise if you go this, present this to your boss. Yeah, this is a game changer for me. Okay, this is a hello world, probably not very representative. I tried, and the team also tried to, yeah, sorry, I have here the link to the benchmark, so you can try it yourself and see the result yourself. You have the code, the instruction, everything. The other benchmark is a file to DB. So this is reading data from a file, ingesting it in a database. We have a more realistic use case here with 1 million items. We have real I/O from disk. We have CPU to map data and so on. So this is a more realistic application. Okay, startup time. The JVM app, almost a second. Natively compiled, 40 milliseconds. Again, 20 times faster at startup, but yeah, that's huge. For the total execution time, the JVM version took 37 seconds. It's 1 million items. The native executable took 15 seconds, so it's 2 times faster. And I think here, because we have a lot of I/O, I think GRAALVM cannot improve the performance of I/O. Yeah, this is disk I/O, so you cannot really improve it. You can improve memory usage, CPU, and so on, but I/O, it was expected that we don't have a lot of improvement here. But still, 2 times faster or even more, it's already a great performance improvement. So, yeah, again, you have a link to the benchmark. You can go there. There is like a utility to generate the input file with 1 million items, and then a couple of commands, and you can run the benchmark yourself. So how can I natively compile my application? The easiest way is to use start.spring.io. So you can add the native dependency. Okay. And then you edit, of course, your application. And then after that, you just use Maven or Gradle, and you use the native compile goal with the native profile. So this is coming from Spring Boot. And once you run this command, you should have a natively compiled executable that you can run and test. Again, one command away, you have a natively compiled app that runs 20 times faster than a regular app. Yeah. Kudos to the Spring Boot team for making this as easy as one command away. A lot of efforts have been has been done on this. So yeah, it's amazing to have this single command. So those are the major features. We have a lot of other features, but I'm not going to present them in detail. But yeah, we have a new Maven BOM to import dependencies in a consistent version. We use UTF-8 by default. We added transaction support in the Job Explorer, Job Operator, and so on. We improved the system command tasklet with a new interface to decouple the execution of the tasklet itself from the execution of the command on the system. Yeah, we did this because we run we tend to run now batch applications in containers, and at some point, for many use cases, we want to shell out from the batch Java application to the shell and come back. So we have new interface there. A lot of test utilities improvement, documentation update, and so on. So those are the other features we have in batch 5. So that's all for features. I'm going to talk about pruning, what we have removed in this release. We removed the support for SQL Fire as a job repository. So SQL Fire was deprecated since 2014, almost 10 years ago. So it's a good time to remove it in batch 5. We removed GemFire support as well. We had an item reader for GemFire. The issue is that the item reader was based on Spring Data GemFire, which is not supported anymore. So we had to remove it. We removed the implementation of the GSR 352. This is because of a lack of adoption of the Spring implementation. So we removed it. And also we removed all previously deprecated APIs. So 4.1, 4.2, 4.3, we typically remove them in the next major release, and this is the time if you have used a deprecated API, yeah, you should see it removed in this release. I give you a couple of links where you can find all the changes, the list of the removed APIs, features, and so on. Okay, now let me talk about the support policy. I think this is important. The support policy for all Spring projects follow the VMware Tanzu, which is basically 1 year of support for minor versions, 3 years of support for major versions. And Spring Batch is no different. We follow the same policy. And we typically follow the same support period as Spring Boot. So as long as there is a Spring Boot version that brings a Spring Batch version, that Spring Batch version will be supported with the same timeline as the Spring Boot version. For example, Spring Batch 5 is brought by Spring Boot 3.0, so it will have the same lifetime support period as Spring Boot 3. Spring Batch 4.3 is brought by Boot 2.7, so it will have the same support period. Now, there is a particular case where if a Spring Boot version, like if Spring Boot releases another version, let's say 3.1, which will be released today, by the way, Spring Boot 3.1 will bring also Spring Batch 5.0. So Spring Batch 5.0 will be supported as long as Spring Boot 3.1 is supported as well. So the idea is that every time we have a Spring Boot version that brings a Spring Batch version, that Spring Batch version has the same support timeline. And in all cases, you have like a support page on the website. You can check the dates. They should align with Spring Boot. And here we have like the 4.3 line and 5.0 line. Something maybe important to notice here is that 4.3 will be supported until November this year, which is 1 year after we release 5. So you have 1 year timeline to migrate from 4.3 to 5.0. Again, here, if you have, sorry, you have a question? Ah, okay. So again, if you have any question, if you need support on migrating from 4.3 to 5, please reach out to us. Here you can ask a question on Stack Overflow. You can send me an email. Don't ask ChatGPT. It won't answer. It's capped at 2021, so you can't answer this kind of questions. But anyway, you have still like 6 months from now? No, 4 months maybe for 4.3, but yeah. We have commercial support after that, but this is the end of the OSS support. So, what's next? In the short term, we are supporting 5.0 and 4.3. We released 5.02 just yesterday, so we will continue on supporting these versions. And we will have Spring Batch 5.1 in November, so it will be based on Spring Framework 6.1. And what we have here, so we are aiming at improving the getting started experience. So this is, I think this was the most asked improvement in the Spring survey. So people were asking, yeah, the getting started experience is not very good, so we're here, so we will improve this in 5.1. We will improve the guides, samples, and so on. Another major theme will be virtual threads. Virtual threads are coming in JDK 21. So we will make sure that Spring Batch 5.1 runs correctly with virtual threads. So our goal is for you as Spring Batch users to have the correct behavior by using either virtual threads or platform threads. This is our goal. And another idea, we have some ideas here to revisit the implementation of the chunk-oriented processing model. So maybe we will leverage virtual threads to improve concurrency, to improve the implementation itself. Maybe we will have more throughput and so on. Yeah, we have a lot of ideas here. We are experimenting with them. We will be sharing them on GitHub, so you can see everything we do. You can contribute with ideas. It's a new implementation, so yeah, you are welcome to contribute. Just want to tell you that those are goals, not commitments, so we are trying our best, but if we don't ship those in 5.1, don't be surprised. So, and before leaving you, I have a last slide. We have Spring Academy that was launched recently. Of course, this is a great place to learn about Spring from the experts. We have a 20% discount for conference attendees. You have the code there. It's at checkout by June 4th. So yeah, this is 20% of the Pro subscription. Yeah. And this is the best, I think, the best place on the internet to learn about Spring, and really great stuff there. That's all I have. Thank you for your time.